Assalamualaikum and hi to everyone. In today's videos, our group will be present about application of differentiation, which is related rate. Okay, now let me introduce our group members. First, we have Muhammad Shariful Azharuddin. Second, we have Mio Shakil Irfan. Third, we have Murni Sahira, and lastly me, Hani Danisha. Okay, now I will talk about what is differentiation. Differentiation means the rate of change of one quantity with respect to another. The speed is calculated as the rate of change of distance with respect of time. If y equal to fx, that is differentiable. Then, the differentiation is represented as f prime x or dy dx, or we call it as derivative of fx.
In this chapter, there is 4 applications that we learn, which are analysis of the function, related rates, applied maximum and minimum, mean value theorem. For this video assignment, we as a team choose related rates as our topic discussion. So, what is related rates? Related rate problems involve 2 or more variables that change at the same time, possibly at different rates. If we know how two variables are related and how fast one of them is changing, then we can figure out how fast the other one is changing. The rate of change is usually with respect to time. Objectives. In a similar vein, the objective in a related rates problem is to determine the rate at which one quantity changes by leveraging the rate of change of another quantity, which might be more readily measurable. The approach entails discovering an equation that establishes a connection between the two quantities, followed by employing either the chain rule method or implicit method. So, problem statement 1. The radius of the base of a right circular core is decreasing at the rate of 4 cm per minute, and the height is increasing at the rate of 6 cm per minute. At what rate is the volume changing when the height is 12 cm and the radius is 6 cm?
To solve the problem, we will use the implicit method as the way to show our work, and it is easy to understand. For the first step is write volume of cones formula, which is V equal to 1 over 3 pi r square h. And for the second step is identify two things, which is the given information and the unknown. For the given information, the first given information that stated in the problem statement is the radius is decreasing at the rate of 4 cm per minute, which we can assign as dr over dt equal negative 4 cm per minute. And for the second given information is the height is increasing at the rate of 6 cm per minute, which we can assign as dh over dt equals 6 cm per minute. And for the unknown that are stated in the problem statement, at what rate is the volume changing when the height or h is 12 cm and the radius or r is 6 cm. So we know that we have to find the dv over dt when h is 12 cm and r is equal to 6 cm. So for the third step is differentiate volume of cones formula, which is V equals to 1 over 3 pi r square multiplied by h. So it will be dv over dr equals to 1 over 3 pi r square dh over dt plus h multiplied 2 over 3 pi r dr over dt. So for the equation, we will use product rule to solve it, which is u equals to 1 over 3 pi r square du prime equals 2 over 3 pi r dr dt, and v equals to h and v prime equals to dh over dt. So the formula of product rule is dv over dt equals u multiply v prime plus v multiply u prime. And for the first step, we have to assign the value of height and radius in dv over dr. So it will be dv over dt equals to 1 over 3 pi, and r is equal to 6 square, and 6 plus 12 multiply 2 over 3 pi 6 and multiply by negative 4. And for the final step, we have to solve the final answer, which is dv over dt equals to 1 over 3 pi 6 square multiplied by 6 plus 12 multiply 2 over 3 pi 6 multiplied by negative 4. And we will get dv over dt equals to 72 pi minus 192 pi. And we will get dv over dt equals to negative 120 cm cube per minute. But it is not the final answer because the volume must be in positive value. So the final answer is 100 dv over dt equals to 120 cm cube per minute.
Next, we move to the second problem statement. If the radius of a sphere is increasing at the rate of 4 cm per second, how fast is the volume changing when the surface area is 16 cm square? Using the hint, the formula of volume of sphere, which is 4 over 3 pi r cube, and the formula of surface area, which is 4 pi r square. In order to solve this problem, we will use implicit of differential method. First and foremost, we need to write the volume of sphere's formula, V equals to 4 over 3 pi r cube. Secondly, we need to write the surface area of sphere's formula. Thirdly, we need to identify two things, which are the given information about the radius that is decreasing at the rate of 4 cm per second, or dr over dt equals to 4 cm per second. And the unknown, which is how fast is the volume changing when the surface area is 16 cm square, or dv over dt equals to unknown when surface area is 16 cm square. The fourth step is to differentiate volume of sphere's formula. V equals to 4 over 3 pi r cube can be differentiated to dv over dr equals to 4 pi r square. For the fifth step, we need to assign the value surface area equals to 16 cm square to surface area formula. Surface area equals to 4 pi r square, and the surface area given equals to 16 cm square. The final assignation will result to pi r square equals to 4 cm square. Finally, we can solve for the final answer by using the formula invented earlier, dv over dt equals to dv over dr times dr over dt. We assign the values of dv over dr, which is 4 pi r square, and the value of dr dt, which is 4. And we get the final answer, which is dv over dt equals to 64 cm cube per second.
For the conclusion, by this calculation, we can conclude differentiation method is used to compute the rate of change. In addition, understanding of question is vital for us to answer the question very well. Instead of that, we can apply this method in our daily life if we understand what is related rate is.